Okay, let's talk a little bit about resistor color codes. We've got this table here that you can help to understand how these work. We've got, this is called the first digit, or what I call the first most significant digit. It's like your age. Your first most significant digit in your age, if you're in your 20s, is a 2. If you're in your 30s, it's a 3. Denotes the largest number. The second most significant digit, this is sort of a little inaccurate. This is for a different type of resistor, but I'll show you how it works here. For a 4-band resistor, this is a 3-band, so it's got a first and a second and a multiplier and a tolerance. But what we're going to be using primarily, in the card that came in your electronics kit shows 4 and 5-band resistors. So this is just, I found on the internet. I kind of like the way it was laid out. So we'll go over it together. So as you can see, these numbers over here denote the color. The color denotes the number. So black represents 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. Now there's a variety of ways of remembering this. I use the way I do it is I look at the first number, the first letter here, B. So I go, okay, well, B, that's black. The next one is brown. So you just got to remember that black comes first, and then after that you got brown, that's another B. Then you got red, and then you got orange, right? You see what I'm doing here? So yellow, green, blue, violet, gray, and white. So it goes, okay, well, bad boys race our young girls, but violet generally wins. So there's a variety of ways. I know a lot of guys will use bad beer rots our young guts, but vodka goes well. There are a variety of ways of remembering that. I will expect you to remember that for the for your tests and exams and etc. And I'll tell you that, to be honest with you, any electricians or electronic technicians, this is one of the very first things that they remember, and it's just embedded in the brain. So once you get this, you're just never going to forget it. So bad boys race their young girls, but violet goes generally wins. Now, as you can see, you do have a G here, and you do have a G here. Way that I remember this is that, well, G for green here, 5, G for gray here, 8. Well, 8's a bigger number than 5. As you get older, your numbers get bigger. Your hair turns from gray to white. So, you can think of it that way. The older you get, the bigger your number. Your hair turns from gray to white eventually. You do have a black and a brown. You just have to remember that the black comes first, brown second, and then you do have a blue over here in between the green and the violet. So there are a couple of things that you have to remember. Let's just take a look at how this works. So we have our first most significant digit over here. So let's look at this one. We're going to do these 4 here. So I'm going to say, okay, brown. Brown represents the number 1. So I'm going to write that there. And then I've got a black. Black represents the number 0. So I have my first most significant digit, my second most significant digit, and then what we're going to do is this is the multiplier, and my multiplier here is brown. And as you can see, brown multiplier is times 10. So I could multiply this 10 times 10, or I could say, well, how many zeros does brown represent? Well, brown represents 1 0, so I could just write 1 0 in there, and that's the same thing as me doing 10 times 10. It just sometimes makes it a little bit easier. And then this is the tolerance. We talked about the tolerance in the last video. So this is the tolerance, and if you have a gold tolerance, then it is always 5%. Okay, let's take a look at the next one. So brown again, brown represents 1. Brown, next significant digit, represents 1 again. Red is a multiplier. Red is a multiplier. And if I go to red, okay, well, I can say, well, red multiplier is times 100. Or I can say, well, how many zeros does red represent? Well, red represents 2 zeros. Don't write the number 2. Put in how many zeros it represents. So now I know that I have 1100 ohms. And silver, if we look at silver, this is silver over here. Silver represents a 10% tolerance. And it's easy to remember the two here. You got a 5% tolerance and 10% tolerance. Which is better, gold or silver? Well, gold is better, so 5%. A lower tolerance means that it's a better quality resistor. Better quality, gold over silver. So in this particular case, I would have 1.1 kilo ohms plus or minus 10%. Okay, let's take a look at the next one. We got red, green, blue, gold. So red, I look over here, red represents the number 2. Green represents the number 5. Blue is my multiplier. Blue is my multiplier. So I look at blue, well, that's okay, times a million. All right, well, let's just say, how many zeros does blue represent? Well, it represents 6 zeros, so I'm going to draw 6 zeros in there. And gold, I'll put that over here. Gold, we know is 5%. So if I'm looking at this, I've got 25 million ohms, which is the same as multiplying my 25 times million, 25 million. So I've got this one, I would say it is 25 mega ohm plus or minus 5%. So fairly easy. Okay, let's take a look at the green, violet, orange. What I'd like you to do is stop the video, pause it here, do the green, violet, orange. Notice that there's no tolerance on here. So what I want you to do is try to figure out what's going on here. So hopefully you saw the video, and let's take a look at green. Green represents number 5. Okay, so green represents 5. Violet, oh boy, violet, spell check, somehow took care of that. Violet represents the number 7, and orange, so we look at orange here, and orange is 3. It represents 3 zeros. So I have 57,000 or 57 kilo ohms, but notice there's no tolerance value here. The tolerance is not denoted. And if the tolerance is not noted, then it's automatically 20%. So a 4-band resistor that has only 3 bands represents, in terms of its tolerance, a